Hi everybody. Today I'm going to be going over problem 3.10 from the bingo card homework problems. This problem here has to do with projectile motion, and the story that the problem goes with is that here's this person who is cliff jumping into the water below, and so he's on this cliff that's 9 meters high, but the problem that he has is that there's this ledge that sticks out 1.75 meters wide. And so the question is asking what does the velocity need to be for this person to be able to get into the water without hitting the ledge? And so to do that, we're going to need to use some of our equations that we've learned, or just one of them really. So since we're dealing with height, we'll want to deal with this one. So it's y equals v 0 of y, so the initial velocity of y, times time plus 1/2 gravity times time squared. Now, the nice thing about this is since this person is going only horizontally running, that the initial velocity in the y direction is just going to be 0 because there's no change in y in the beginning. And so this is just 0, which means that that time doesn't matter anymore. It just cancels out because anything times by 0 is 0. So that clears up our equation quite a bit. So it's going to be y equals 1/2 gt squared. So I'll rewrite that just to clean it up a little bit. So before we can figure out how the velocity of this person, we need to figure out the time that it would take to get from here, to wherever the impact is going to be. And so to do that, we can use this equation here and plug in the values that we know to be able to find the time. And then from there, we'll be able to use the time to find the velocity. So what we'll do, and y is just the height here, so that's 9 meters. Equals 1/2. And then the force of gravity is 9.81 meters per second squared. Actually, before I solve it like that, let's isolate time. That's going to make it a lot easier. So instead of plugging in the numbers now, let's get to our desired variable. So we're going to do that by multiplying 2 over, so 2y equals gt squared. And then that will divide by gravity, so 2y over g equals t squared. And now we'll just need to take the square root of this whole left side, and we'll end up with So now that we've isolated t, now let's plug in those numbers, because that was a lot easier to do than trying to do all the math with canceling out and getting everything over to the right side. So now we've done this. Remember, why we know it's 9 meters. That's the height that this person is going to be falling. So the time equals 2 times 9.0 over 9.81. And that's all in a square root. So when we do that, the time ends up being 1.35 seconds. So not very long. So whenever I'm doing problems like this, I always like to ask myself, does that make sense? You know, because a lot of the times in physics, we can kind of check ourselves loosely as we go along. And so I always ask myself, like, does that make sense? Does it make sense that it would take about, just under 1.5 seconds to fall 9 meters? And being that the acceleration due to gravity is 9.81, meters per second squared, that sounds pretty good. So that sounds good to me, which, you know, it's just one of those little things I like to do every time I solve a problem, just to make sure that I'm on the right track. So that looks good. So now what we need to do is we need to use an x equation, right? Because now we know the time that it takes to get to the ground, but we need to see what velocity is needed in order to get past this ledge that's 1.75 meters wide. So now what we do is we're going to use one of our other equations, which is x. So it's going to be x equals v0 of x. So the initial velocity of x times time. So the only difference, you know, we don't deal with gravity in this one because gravity is only in the y direction. So we have the initial velocity times time, and this is in the x direction. Well, we already know what x is, and we already know the time. And this is the variable we want to find. So now what we do is we just plug in, or let's go ahead and isolate our variable. So the v equals x over t. So now let's plug in the values that we already know. So we know that x is 1.75 meters and our time is 1.35 seconds. So v of x equals 1.75 meters over 1.35 seconds. And when we do that math in the calculator, we end up with the initial velocity in the x direction is 1.296 meters per second, or we'll just round it to 1.3. So that's 1.3, and then remember our units, meters over seconds, which with velocity is correct, so we know that our units work out. So that's 1.3 meters per second. So that's about it. So the minimum speed, the absolute minimum speed of this cliff jumper needs to be 1.3 meters per second. Now, obviously, this person, he or she, would definitely want to be going faster than that because that is going to get barely to the edge. So, but that wasn't, our job was to find out that minimum speed. And so, that's it. We solve the problem, and as long as this person is going at least 1.3 meters per second, they won't hit that ledge and they'll be able to have a fun day cliff jumping.